In this question, we're asked to find the shortest distance between the plane, x plus y plus z equal to 3, and the point S, and it's got a position vector 1, 1, 0. So let's draw a picture. Here's my plane, and here's my point somewhere below or above, it doesn't really matter. And we want to find the shortest distance between the plane and the point S. And the thing to realize is that the shortest distance will be where there's a line that connects S at right angles to the plane. So if we were to draw a line on the plane, it would connect at right angles. So that will be the shortest distance, not something that intersects the plane at an angle, because that would be longer. An angle over here, let's say I had an intersection here that is intersecting at some angle phi, which is not 90 degrees. The shortest distance will be this 90-degree line here. So the way to go about this one is to realize that any line perpendicular to the plane is in the direction of the normal vector to the plane. Okay, what we want to do is take any point on the plane, call it A, find a vector that connects S to A, so we'll call it SA, and then we remember that the properties of the scalar projection. So the property of the scalar projection says a vector SA in the direction of the vector n is given by, so the scalar projection. Okay, so we need to find the scalar projection of SA in the direction of n. Okay, so we need to find the scalar projection of the vector S to A, which is just any point on the plane, and we'll learn how to find that in a moment. And we need to find that in the direction of the normal, and that will give us this quantity in red here, this line here. That will give us the quantity from S to a point on the plane, which is exactly perpendicular, and hence the shortest distance. So go back to scalar projection. Scalar projection of SA in the direction of n is our distance, our shortest distance, and that is equal to the scalar projection, which is given as SA, the vector SA, dotted with n hat, which is SA dotted with n divided by the magnitude of n. So the first thing, I guess, is to find n. So let's find n. So n is just the coefficients from the Cartesian equation of the plane, x plus y plus z. So n must be, that's right, 1, 1, 1. We also need the magnitude of this vector, so we may as well quickly compute that. It's the square root of 1 squared plus 1 squared plus 1 squared, otherwise known as root 3. We also need SA. Now that's a little tricky. SA is going to be the point A minus the point S. So how do we find a point A on the plane? And the simplest and best way to do it is to just let x and y equal 0. I assure you that is where the plane intersects the z-axis, and that's the best way to find a point on the plane. So z is equal to 3, so therefore, and I said x and y is equal to 0, so this point must be 0, 0, 3. So therefore, oh sorry, having some technical difficulties, SA will be the point A, 0, 0, 3, minus the point S, which was 1, 1, 0. So this vector is going to be negative 1, negative 1, 3. So the shortest distance is equal to the dot product of negative 1, 3, dotted with the normal, 1, 1, 1, divided by the absolute value of the normal, or the magnitude. So negative 1 times 1 is negative 1, plus negative 1 times 1, which is minus 1, plus 3 times 1, divided by root 3. That's equal to negative 2 plus 3, so it's equal to 1 on root 3. And we are asked for distance, so we'll just say units. of length. Okay, so I hope you can follow that. It's a little, you really need to understand what scalar projection is and realize that, yeah, this red bit here, the distance we're trying to find, is the scalar projection of the point, a vector S to a point on the plane A in the direction of the normal vector. Okay, so try and reproduce this in the next question and check your solutions, and make sure you haven't got a lot of the exercises on the exercise sheets. And if you still don't understand it, please leave me any questions, comments, and I'll will respond. Okay, good luck.